Now, we've been saying anytime we're integrating a power of x other than -1. What about the -1 case, okay? That's the same thing as this, 1 over x dx, if I rewrite this part. Well, we have a formula for that. The antiderivative of 1 over x is going to be the natural log of the absolute value of x plus c. Memorize this formula. You're going to see it over and over and over and over again, okay? So, now, let's say you're taking a test and you're nervous and you're scared you'll screw this one up. Well, what if you tried to integrate this by adding 1 to that? You would have x to the 0. Then what would happen? You try to divide by the new exponent, and you know you can't do that, right? So that should tip you off to, there must be some formula or something. So that's whenever you would use that formula. All right, let's take a look at doing this example. Suppose I'm told to find an antiderivative of 7 over x dx, okay? That's the same thing as writing the antiderivative of 7 times 1 over x dx, right? If I factor the 7 out the top. Well, the 7 is a constant that's being multiplied, so we can bring it to the outside and say 7 times an antiderivative of 1 over x dx. So that's 7 times, what's this antiderivative? We were just told it's the natural log of the absolute value of x plus c. That's my antiderivative there. All right, let's take a look at what's next. What is next? Just go ahead and call this A. What about an antiderivative of 35 x to the 4th minus 4x dx? What if I want an antiderivative of that? Well, what could I do here? I could say 35 times the antiderivative of x to the 4th is x to the 5th over 5 minus that 4 times, what's the antiderivative of x to the 1st? X squared over 2, but I need my arbitrary constant c. So what does this give me? 7x to the 5th minus 2x squared plus c. B. What if we take the integral of 3 dx? What if I say take the integral of 3 dx? Well, what's understood in here? Isn't this understood to be 3 times x to the 0 dx? Because x to the 0 is just 1, right? So wouldn't that be 3x to the 1st over 1 plus c, or 3x to the 1st, right? How about c? How about the integral of x? I'll tell you what, let's do this. The integral of z dz instead. How do I do this one? Well, what's my exponent here? 1. So add 1 to the exponent, divide by the new exponent, plus your c. There you go. D. D is a dog. What about the integral of sine of x dx? Oh, how dare you, Mr. Faulkner, throw a trig function in there. Well, guess what? You're going to see this stuff. Now, how did I learn how to integrate? I learned if I have a power of x other than -1, what to do. Well, this is certainly not a power of x, right? Then I learned if I have x to the -1, that's basically the natural log of the absolute value of x, right? But what about this? What am I looking for here? I'm looking for an antiderivative, right? A way to do this problem is think, what do I take the derivative of? What function do I take the derivative of to give me sine of x? What do I take the derivative of to give me sine of x? Is it cosine of x? No, if I take the derivative of cosine of x, I get negative sine, not positive sine, right? But what if I put a negative in front of there? What if I take the derivative of negative cosine of x? That'll give me negative sine of x or positive sine of x, which is what I have, but I need my plus c here. Couldn't we have really done that over here, actually? In other words, I'm looking for, what do I take the derivative of to give me 3? Wouldn't that be 3x? Take the derivative of that. Gives you 3, right? But you need your constant. Actually, I could have done it here, too. It would have been a little more complicated, but I could have done it there. Could I have done it here as well? What do you take the derivative of to give you z? Well, wouldn't that be z squared? Not exactly, because that'll give you 2z, right? I want just z. But what if I put a 1/2 out in front like this? And I put plus c. Now if I take the derivative of that, I will get that, right? How about, let's see, that was D. How about E as an elephant? E as an elephant. For part E, I have the integral of secant of x squared dx. Oh man, I wish I would have memorized those earlier during the semester. Alright, that's not a power of x, right? So what do? I think, what do I take the derivative of to give me secant squared? What do I take the derivative of to give me secant squared? Wouldn't that be the tangent of x? Yeah, derivative of tangent of x gives me secant squared, but I need my plus c. How about f? What about the antiderivative or an antiderivative of 1 over the square root of 1 minus x squared dx? Is that a power of x, first of all? That I could just add 1 to divide by the new exponent? No. Is it x to the negative 1? No. So what's my only other option right now I learned? What do I take the derivative of to give me this? Think back. What did we take the derivative of that gave us this? Wasn't it the inverse sine of x, or the arc sine of x? Plus my arbitrary constant there. Let's look at G. G, we have the integral of sine of x quantity squared plus cosine of x quantity squared dx. Well, if I try to break this up and take the integral of the sine squared, I don't know what that is. Integral of cosine squared, I don't know what that is either. But what stands out right away about this? That's an identity, right? So let's call all this 1, according to my identity from trig. Well, what's the antiderivative of 1? In other words, what do I take the derivative of to give me 1? Wouldn't that be x? And then plus c, right? G. How about H? Oh, I got x cubed dx. I don't want to do that one. That one's kind of stupid, okay? Let's do, I don't know, maybe something like, no, shoot, we'll just do this. Antiderivative of cosecant squared. Okay? What do I take the derivative of to give me cosecant squared? Is it the cotangent of x? The derivative of cotangent of x will give me what? Negative cosecant. But I have a positive cosecant. So I need to put a negative sign right there, right? Now if I take the derivative of this, I'll get what? Negative cosecant squared times a negative, so that gives me positive cosecant squared plus c. That's why I had y'all memorize all those trig functions. I knew not only would you have to take derivatives of them then, you'd have to what? Go backwards and take antiderivatives. All right, let's come up with a couple of formulas here. Or let's look at a couple of formulas, not really come up with them. Let's suppose I have du over a squared plus u squared. That's going to be 1 over a times the inverse tangent or the arctangent of u over a plus c. In other words, if I have something like du over some number squared plus some variable portion squared, I'm going to write that as 1 over that number that's being squared times the inverse tangent of this variable part over the number plus c. Okay? I mean, another way to write this is 1 over a squared plus u squared du is equal to that stuff. Okay, then I have this one. I have this formula that says, suppose I have du over square root of a squared minus u squared. Well, we learned we used the version of this a little while ago. That's the inverse sine of u over a plus that arbitrary constant c. Memorize those two. They're going to pop up in your homework. You're going to see them on exams. You're going to see them whenever you go on to Calc 2 or you go on to physics or whatever. All right, let's look at part A here. Part A says, let's integrate 1 over 8 times the square root of 1 minus x squared minus 3 over 1 plus x squared, all in parentheses, dx. Let's look at that. All right, maybe what I'll do to make it easier on myself is I'll write integral of this stuff minus the integral of that stuff, okay? So I'm going to do a rewrite. I'm going to say, okay, this is 1 over 8 square root of 1 minus x squared dx minus the integral of 3 over 1 plus x squared dx. Right here, I could pull a 1/8 out of this, and I could say, okay, that's 1/8 times the integral of 1 over the square root of 1 minus x squared dx. And over here, couldn't I factor a 3 out? You call that 1 over 1 plus x squared dx? Sure can. So here we have 1/8 times. Which form does this look like? Looks like the one that has a square root in the bottom, right? Don't I have some number squared minus some variable portion squared? Some number squared? Because 1 is really 1 squared, right? I could put this if I wanted to. That's fine. Minus x squared dx. So what does it say? It says that could be what? The inverse sine, or the arc sine, the inverse sine of u over a. What is u? U is the variable part that's being squared, right? So what's my variable part that's being squared? X over a. A is what? My constant part that's being squared. What is my constant that's being squared? 1. Minus 3 times, how about this part right here? Doesn't this fit the form as a squared plus u squared? So how do I write this? I write it as 1 over the number part that's being squared. Number part that's being squared is 1 there. Times the inverse tangent of the variable part that was being squared over the number part that's being squared. Variable part that's being squared is x. Number part that's being squared is 1. And then I'm going to put my plus c at the end of this. Now let me clean this up. So that's 1/8 inverse sine. X over 1 is just x minus 3 inverse tangent of x plus c. Not too bad. Part B. Part B, we have the integral, let's see, 3/2 x to the negative 1 minus 7 cosecant of x times cotangent of x plus 8 x to the negative 5. Want to take that integral with respect to x, okay? So, I have subtraction, I have addition. What I'm going to do is I'm going to take the antiderivative of this part, then this part, then that part, okay? So how do I take the antiderivative of this term? Well, I have a constant, so I'll pull that out to the front, right? Then I say, what's an antiderivative of x to the negative 1? Well, that's a special case, right? That we said was the natural log of the absolute value of x. Then we have our minus 7, we're going to bring down times. Let's take the integral of this part right here. Okay, that's not a power of x, so I can't just add 1 and so forth, okay? So what I do is I think, what do I take the derivative of to give me cosecant times cotangent? Wouldn't it be the cosecant of x I take the derivative of, give me cosecant times cotangent? Now I've got to be careful here, okay? If I take the derivative of this stuff, what am I going to get? Like if I go over on the side here, do some scratch work, okay? What happens if I take the derivative of this? What do I get? I should get back this part, right? Let's see. Negative 7 times, what's the derivative of cosecant? Negative cosecant times cotangent, right? What's a negative times a negative? That'd give me positive 7 cosecant of x, cotangent of x, right? But I got negative 7. So what do I need to do here? I need to put an extra negative right here, so it'll come out right. All right, plus 8 times, what's the antiderivative of that part? X to the negative 4 over negative 4 plus my arbitrary constant c. Now this was just scratch, so I can erase it. All right, let's see. So that gives me 3/2 natural log of the absolute value of x. Negative times a negative gives me positive 7 cosecant of x. And if I multiply this stuff, I get what? Negative 2x to the negative 4 plus c. Now let's see. Let's suppose I'm really unsure about this right here. I'm really unsure about that term, let's say. What could I do? Remember, take the derivative of this, and do you get back that? If so, you probably did it correctly. What's the derivative of, like I'm checking myself, scratch work again. What's the derivative of 7 cosecant of x? Well, that'd be 7 times the derivative of cosecant. What's the derivative of cosecant? Negative cosecant times cotangent. What does that give me? Negative 7 cosecant of x times cotangent of x, right? Isn't that what I wanted? Sure is, so I probably did that right. Here's my answer. All right, now for our next example, let's pay attention to the directions on this one. This one says, state a corresponding integration formula. State a corresponding integration formula. Integration formula. Okay, state a corresponding integration formula. And what I'm going to have is this, part A. Part A is going to say, let's find the derivative, or it says they're finding the derivative with respect to x of the square root of 11 plus 8x squared, okay? And they give you that that's equal to 8x, over the square root of 11 plus 8x squared like this, okay? Now, what do they want me to do? They want me to state a corresponding integration formula. So if I take the derivative of this square root stuff, I get this, right? So what if I take the antiderivative of this or an antiderivative of this? What should I get back to? What I started with right here. So my integration formula is going to be this. The integral of 8x over square root of 11 plus 8x squared. Don't forget about your dx. What should that give you whenever you take the integral of this? It should give you what you started with. Square root of 11 plus 8x squared. Let's see. I'm going to make up a part B. You don't have this one in your notes, but let me make this one up, okay? Let's say we had the derivative with respect to x of the sine of x. Well, y'all can tell me right away that's the cosine of x, right? Now, what am I saying? I'm saying if I take the derivative of the sine, I get the cosine, right? So what happens if I take an antiderivative of the cosine of x? What should I get? I should get what? I'm asking basically right here, what do I take the derivative of to give me cosine of x? Well, what did I take the derivative of to get the cosine of x? Sine of x. Now, I need a plus c technically there, okay? Same thing here. I forgot to put my plus c. Let's put a plus c. So what are you basically doing here? You're basically showing that what? Taking a derivative and integrating or inverse operations. This now is part B from your notes. I'm going to call it C here since I inserted another problem actually. They have this. The derivative with respect to x of x times e to the 9x. And they say that's 9x plus 1 in parentheses, 9x plus 1 in parentheses, times e to the 9x. So what happens if I take the derivative of this part? I get the right-hand side, right? So what happens if I take the integral of the right-hand side, 9x plus 1 e to the 9x dx? What should I get back? Remember what this is asking. This is asking, what do I take the derivative of to give me this inside part? Well, what did we take the derivative of to give us this? We took the derivative of what? X times e to the 9x, this stuff, but we need a plus c, okay? There is my corresponding integration formula right there. Okay, they're just trying to reinforce that what taking a derivative and integrating or inverse processes.